Okay, let's follow up with another health-related paper that's new, came out in 24. Seemed to have been submitted in 22, so it sat around for a while. But it's basically a meta-analysis on global change drivers and the risk of infectious diseases. Meta-analysis, as you know, is analysis of published reports, papers, peer-reviewed studies to conclude, different regions with different studies, bringing them together in a synthesis. And I will just read the main results. There's lots of detailed statistical analysis that I'm not going to get into, but make some good points, so I wanted to include it here. Anthropogenic change is contributing to the rise in emerging infectious diseases, which are significantly correlated with socioeconomic, environmental, and ecological factors. Studies have shown that infectious disease risk is modified by changes to biodiversity, climate change, chemical pollution, landscape transformations, and species introductions. However, it remains unclear which global change drivers most increase disease and under what contexts. So it's adding some finer points with this meta-analysis. Here we amassed a data set from the literature that contains 2,938 observations of infectious disease responses to global change drivers across 1,497 host parasite combinations, including plant, animal, and human hosts. We found that biodiversity loss, chemical pollution, climate change, and introduced species are associated with the increases in disease-related endpoints or harm, whereas urbanization is associated with decreases in disease endpoints. Natural biodiversity gradients, deforestation, and forest fragmentation are comparatively unimportant or idiosyncratic as drivers of disease, so they may be very location specific. No overall global picture emerges out of deforestation, forest fragmentation, and biodiversity gradients. Overall, these results are consistent across human and non-human diseases. Nevertheless, context-dependent effects of the global change drivers on diseases were found to be common. The findings uncovered by this meta-analysis should help target disease management and surveillance efforts towards global change drivers that increase disease, specifically reducing greenhouse gas emissions, managing ecosystem health, and preventing biological invasions and biodiversity loss could help to reduce the burden of plant, animal, and human diseases, especially when coupled with improvements in social and economical determinants of health. So the idea of One Health or planetary health, I have sections on those that give you a sense that this is a good message, because biodiversity loss is an important part of the disease outcome. So is climate change, chemical pollution, and landscape transformation. So One Health wants to worry about animals, humans, ecosystems together, and this says that's the best way to do things, right? So this is a figure. I'll just show two figures. So you're looking at biodiversity change, chemical pollution, climate change, habitat loss or change, and introduced species. And you can see that rich countries here have lots of dots in habitat loss or change, and so do some of the developing countries like China and India, as well as African countries and so on. So there's no systematic pattern. Introduced species much more common here in Europe and US, North America in general, not so here compared to these, and here when human beings moved in later, and so on and so forth. Without going into too many details, the number of effect sizes, so you have biodiversity change, chemical pollution, climate change, habitat loss and change jumps out. Introduced species, they are all of similar order of magnitude. And when you look at specific species, you have arthropods, bacteria, fungi, helminth, protists, and viruses. So that tells you, if you read the caption here, the number of observations across ecological contexts, A to F, are summary of the number of observations, that is effect sizes, in the infectious disease database across the following ecological context. So these are, since it's a meta-analysis, it's looking at sample sizes in some sense. So the papers report on various topics like biodiversity change, and habitat loss or change is always an attractive target because you have lots of satellite data to do these sorts of things, and then you have various other reasons why you have certain animal species, disease subjects that are being looked at. Here you have again amphibian, reptile, anthropod, bird, fish, mammal, mollusk and plant, and you have venues, habitats and human parasite status. So I won't go into the detail. The main point I want you to get out of this, if you don't want to read the paper, is that meta-analysis gives you some idea. For example, the effects of 5 common global change drivers on infectious diseases, biodiversity change. This is a statistical measure, and you can see it jumps out here. Chemical pollution, climate change, habitat loss, so is a negative coefficient here, and this is introduced species. The effect of 5 common global change drivers of on infection diseases, then biodiversity change, climate change, chemical pollution and introduced species are associated with increases in disease related endpoints or harm, that is introduced species having fewer parasites. Habitat loss or change, HLC, was associated with significant decrease. Here you have in the endpoint, disease endpoints. Number of studies and effect sizes for each driver are shown in parentheses, so you can see the statistical details over there. The displayed points sorry, the number of studies and effective size K for each driver are shown in parentheses. The displayed points represent the mean predicted values with 95% confidence level from a meta-analytical model that separate random intercepts for the study. Global change drivers effect are significant when confidence intervals do not overlap with 0. So here you are just outside 0. If you go across 0, then you don't have any significance, and none of these do that. Okay, so keeping all that in mind, I'll just jump to conclusions and caveats. There are a lot of other details in the meta-analysis of the paper. If you want, you have to follow up. Here we revealed that biodiversity loss, climate change, chemical pollution and enemy release associated with introduced species increased disease responses or disease related harm, whereas urbanization caused decreases in disease. This has to be understood better. You can read the details. All of these results were generally consistent across human and non-human diseases, although other context dependencies were common. Endpoints from parasites with complex life cycles, such as macroparasites and vector-borne pathogens, decrease more with habitat loss and change, increased more with biodiversity change, and responded less strongly in response to introduced species compared with endpoints from parasites with simple life cycles, and ectoparasites increased more in response to introduced species compared with endoparasites. Obviously this is just a meta-analysis, it's not going to give you any details, but let's read some more. We hope that our analysis will facilitate disease control, mitigation and surveillance efforts globally, ultimately improving wildlife and human health and pandemic preparedness. However, there are important caveats for using these analyses in decision making. So even if you don't know the causality, these relations tell you how to monitor and surveil the systems to manage diseases and be prepared for pandemics and so on and so forth. So first, the relationships that we identified might not hold past the range of conditions included in this meta-analysis, and we therefore advise against projecting beyond these conditions. So if you want to add climate change to these things, the story may be more complicated. Secondly, we treated the global change drivers in this meta-analysis in an unbiased and equal manner. However, from a policy perspective, the rates of change of the drivers and their relevance to current and future epidemic and pandemic risks are also crucial, which are not considered here. For example, some subcategories of drivers such as ultraviolet radiation associated with ozone depletion require less attention because they have already been rectified by global agreements such as Montreal Protocol. Other drivers are expected to asymptote or even improve in certain parts of the world, such as habitat loss in upper income countries as they pursue reforestation. Finally, some drivers are expected to worsen through time and are associated with increases in disease risks such as climate change and biodiversity loss, and these drivers might therefore necessitate the greatest policy attention. So that's useful in terms of broader guidelines on where to put resources. The third caveat is that there are few studies in this meta-analysis on interventions to remediate the effects of global change on disease. So mitigation impacts of reduced emissions and so on are not included here, or even afforestation. There is considerable evidence that simply reversing the magnitude of global change drivers can be insufficient to fully counteract their effects. Consequently, we need more tests of interventions to remediate the highest priority drivers described herein, and efforts to evaluate whether ecosystem restoration can be used as a lever to manage disease. So you deforest and loss of biodiversity, etc., happens with urbanization, agriculture, general habitat loss, and so on. But there is a hysteresis, so restoring those doesn't necessarily bring you back in terms of diseases. Finally, most studies in this meta-analysis consider the effects of a single stressor or global change driver on infectious disease endpoints, despite most organisms experiencing several of these factors concurrently and many drivers being interconnected. So when you do this kind of meta-analysis looking at each factor as if they're independent, you can end up with potentially misleading conclusions. For example, climate change and chemical pollution can cause habitat loss and change, which in turn can cause biodiversity loss and facilitate species introductions. Right? Invasive species move in. If you lost bees, dragonflies, fish, and so on, you can have all kinds of cascades of multiple factors that are not considered here. And they are related through climate change, pollution, habitat loss, and so on, right? It is unclear whether global change drivers generally interact additively, antagonistically, or synergistically, and future studies should therefore more thoroughly examine their interactions, interdependencies, and relative contributions to disease risk. Importantly, greater effort is needed to identify win-win solutions that address multiple societal stressors such as disease, food, energy, water, sustainability, and poverty challenges. Although our data suggests that climate change and biological invasions and loss have a part in wildlife and human diseases, all of these factors also can contribute to exacerbate and trap people in rural poverty, which is the strongest predictor of environmentally transmitted infectious diseases on the planet. Thus, leveraging the intersection among environmental, social, economical, and political dimensions will not only be necessary to effectively mitigate against increases in diseases associated with global change, but will also almost certainly be required to meet the United Nations Sustainable Development Goals targeted at managing numerous codependent global grand challenges of the 21st century. I think it's useful, this particular paper, so you can I don't know what it's doing, sorry about that. It's very useful, and hopefully it can convert into useful guidelines for policies, disease management, surveillance, early warnings, and mitigative actions, and how to combine adaptation and mitigation with health considerations as well as sustainable development goals. So let me leave it there. It's a rather brief introduction to the paper, which has lots of details, and with so many papers being analyzed, you have lots of citations that you can follow up on if you are interested in this topic in further details. Okay, I will leave it here then.